right, we can also do one-sided limits. And these are exactly like we were doing with our tables and with our pictures. One-sided limits. First thing you do is try plugging it in, but you got to be careful because sometimes your functions aren't defined to the left or to the right of that value. So you got to kind of think about the graph. So here, let's consider y equals square root of x minus 3. His domain, we're not allowed to take the square root of negative. X minus 3 must be greater than or equal to 0. His domain, x must be greater than or equal to 3. His graph looks like this. So this question is saying, as I'm approaching from the left, that's not -3, as I'm approaching this graph from the left, what y value am I approaching? I don't have any y values over here. Nothing's over here. This guy just doesn't exist. There's nothing over there. This one says, as you're coming in from the right, what value are you approaching? Oh, there, same thing I would get if I plugged in 3. Square root of 0 is 0. So one-sided limits, it's not as simple as just plugging in. You got to think about the domain and you got to think about the graph. Or with piecewise functions, you got to think about which function are you using in a particular region. So we could graph this guy here if we wanted to. Or we could just kind of think it through. This is saying, I want you to use this function. I want you to tell me what the y values are doing as x is getting closer to 2 from below. Using that right there means using x's less than 2. So that means using this top formula. In other words, for this limit, I'm just going to plug in to the top formula. So what do we get? That's 8 minus 3. We get 5. That limit is 5. But what about if I approach from the right? That right there means you're using x is slightly bigger than 2. That means I'm going to be using the bottom formula because I use him for x is bigger than 2. So 2 minus 3 will be -1 squared, which is +1. Now, we could see all that if we graph it. Like, if you don't believe this, graph this guy and check it yourself. Remember, limits only exist if both one-sided limits exist and agree. Here, that doesn't happen, so this guy does not exist. Right? Let's try this guy. Well, maybe let's factor that bottom and see what's happening. If I pull an x out, oh, see, I've got an x minus 2 in the bottom. He's the one that's causing the problem. I can't just plug in. I've got a domain issue. This guy is not defined at x equals 2 or even x equals 0. Oh, so I can't just plug in. I'm going to have to look at the graph and think about this. Or I'm just going to have to plug in values really close to 2, but a little bit below. So if we just try plugging it in, what do you get? You get 2 minus 3, -1, over 2 times 0, 0. That's not 0 over 0. Those ones we did before, it was always 0 over 0, which meant something canceled. That ain't going to happen here. Nothing's going to cancel here. This limit's not going to exist, but we can still write it. We can still convey information. We're going to have an infinite limit is what's going to happen here. Anytime you get not 0 over 0, you've got yourself an infinite limit. And technically the limit doesn't exist, but we still either write infinity, negative infinity, if it's one of those. So let's maybe just take a look at this graph. Okay, if we've got our graphing calculator, we can just throw this guy into our graphing calculator, and we can just look at the graph and see what happens as x is approaching 2 from the left. So here's 2. I want these guys that are just a little bit below 2. I can see this graph is going up to positive infinity. If I didn't have my calculator handy, I would just plug in values really close to 2, but just slightly smaller, like just 1.9. Plug it in and see what happens. If you get a positive number, it's positive infinity. If you get a negative number, it's negative infinity. Now you can't plug in any value. I can't plug in, negative 13. I'm way over here. It's got to be close to the one you're looking for. So go just like 0.1 below it. That's only if you get not 0 over 0. So maybe you should write this down. If you get 0 over 5, the answer is 0. If you get 0 over 0, that means you're going to be able to factor and cancel something and try again. If you get 5 over 0, it's either positive or negative infinity, if it's a one-sided limit. That's a good place to stop on that one.